device. Now we will be discussing various types of inverters, which include, this is the classification according to control technique: single pulse width modulation, multiple pulse width modulation, sinusoidal pulse width modulation, and modified sinusoidal pulse width modulation. The pulse width modulation, this is a popular technique in electrical engineering, in which we control the duty cycle of a signal. So by controlling the duty cycle, we can control the average amount of power to be delivered forward. So the output of the inverter is a square wave signal, and this signal is not used for the load. Pulse width modulation technique is used to control the AC output voltage. This control is obtained by controlling of on and off period of switches, that is the T on and T off. So the duty cycle is defined as T on over total time. Total time includes T on plus T. In PWM technique, two signals are used. One is the reference signal, and the second is the triangular carrier signal. So here in the inverters, we have two types of signals. One is the reference signal and other is the carrier one. The gate pulse for the switches is generated by comparing these two signals. These are different types of PWM techniques. So the single pulse width modulation technique. So single pulse width modulation technique, here we can see that this is one is the reference signal, this is the reference signal, and this is the carrier signal. So reference minus carrier, it will give you the pulse. Reference minus carrier, it will give you the pulse. Similarly, reference minus carrier, it gives the pulse for the second switch. So the overall signal will be like this. So this is how the single pulse width modulation occurs. Reference signal minus carrier signal. Here the carrier signal is in the form of triangular, and reference signal is a square wave. So for every half cycle, the only pulse is available in the control technique. The reference signal is a square wave signal, and the carrier signal is triangular wave signal. The gate pulse for the switches is generated by comparing the reference signal and carrier signal. The frequency of output voltage is controlled by the frequency of the reference signal. The amplitude of the reference signal is AR, and the amplitude of the carrier signal is AC. The modulation index can be defined as AR over AC. So this is the modulation index by which we can control the amount of magnitude of the output signal. The main drawback of this technique is the high harmonic content. So due to the scale wave nature, the harmonic contents are high in this type of inverter. So the other is multiple pulse width modulation. The drawback of single pulse width modulation technique is solved by multiple pulse width modulation. In this technique, instead of one pulse, several pulses are used in each half cycle of the output voltage. Here you can see that now this is the reference signal, which is a square wave, and this is now the multiple pulses are used in one cycle. So now reference minus carrier, so we can see that there are multiple pulses with this technique. So the harmonic contents have been some reduced. So in this technique, instead of one pulse, several pulses are used in each half cycle of the output voltage. The gate is generated by comparing the reference signal and the carrier signal. The output frequency is controlled by controlling the frequency of the carrier signal. The modulation index is used to control the output voltage. So the third is the sinusoidal pulse width modulation, SPWM. This is the most popular technique. This control technique is widely used in industrial applications. Here it is also written here. In the above both methods, the reference signal is square wave. So in the previous method, we saw that the reference signal is a square wave, but in the sinusoidal pulse width modulation, the reference signal is a sinusoidal wave. Here you can see that this is the sinusoid, this is the reference now, and this is your carrier signal. Now reference minus carrier, it will give you the pulses. So you can see that you get high pulses here and low pulses here. Similarly for one switch, for the other switch you get the high pulses here and low pulses here. So overall your output will be like this. You will be having more pulse width during the peak of the sine wave and less pulse width during the zero crossing, around zero crossing of the sine. So this is the beauty of this type of signal, sinusoidal pulse width modulation. In this method, the reference signal is a sine wave signal. The gate pulse for the switches is generated by comparing the sine wave reference signal with the triangular carrier, where the width of each pulse varies with the variation of the amplitude of the sine wave. The frequency of the output waveform is the same as the frequency of the reference signal. The output voltage is a sine wave, and the RMS voltage can be controlled by modulation index. The waveforms are shown. So this is the sinusoidal waveform as PWM. Now the another is fourth one, which is the modified sinusoidal pulse width modulation. Though the characteristics of sine wave, the pulse width of the wave cannot be changed with the variation in the modulation index. So we cannot change the width of the sinusoidal wave. So that is the inflexibility in that, which is covered in this type, modified sinusoidal pulse width modulation. That is the reason PWM technique is introduced. In this technique, the carrier signal is applied during the first and the last 60-degree interval of each half cycle. In this way, its harmonics characteristic is improved. The main advantage of this technique is increased fundamental component, reduced number of switching power devices, and decreased switching costs. The waveform is shown below. Here you can see that this is the sinusoidal wave, this will be the reference signal, and this is the carrier. So the carrier wave, you can see that now we can change the we have the flexibility to change the sinusoidal width. You can see that we have wave. Now this wave is more better than the previous sinusoidal PWM. So this is the advantage of modified sinusoidal pulse width modulation. Now another type is the multi-level inverter. So we will discuss the multi-level inverters in the next lecture. Thank you very much for listening.